Now today's topic is the direction of magnetic field produced by current flowing through that wire. Now first rule is Ampere's swimming rule. Number one is Ampere's swimming rule. Now what is statement? Now the statement is if a person is swimming on a wire in such a way that current enters through his feet and leave him at his head. These are the feet. Here is head. Current enters through his feet and leave him at his head. Then the deflection of the north pole of the magnetic needle, which is placed underneath the wire, will be towards west. This direction is west. Here will be east. Current is flowing from south to north. Now, if a person is swimming on a wire in such a way that current enters from his feet, it does not mean current is flowing through the person feet and leave him from his head. Then the deflection of the needle, then the deflection of the north pole of the magnetic needle placed underneath the wire will be towards the left hand of the swimmer, towards the left hand of the person. This one is needle, it is north pole, it will deflect towards head, towards its left hand. This one is left hand. Here is south, here is north. Current enters through his feet and leave him from his head. This one is rested. Now the second rule is snow rule. Now in the same way we can also explain before snow rule. This one is battery, positive end. Here is key, here is rheostat. Now current is flowing from B to A. Listen, here is north, here is south. A person is swimming over this wire in this way. This one is person, this left hand, feet, here is left hand. Current is flowing in this direction. A needle is placed here. This is north pole. Now here we have changed the direction of current, that is from north to south. Now the deflection must be towards the right hand of the swimmer. The north pole of this one will deflect towards the right hand. In this way, north pole. Now the other rule, that second is snow rule. Snow means S-N-O-W. They have separate meaning. Here the statement is this one: if current through a wire is flowing from south to north, and here is SN. Now south to north and wire is over the needle, then the deflection of the North Pole of the needle placed underneath the wire will be towards west. Now the magnetic field due to a long current carrying wire. Magnetic field due to a long current carrying wire. This one is wire is infinite length. Here is plus infinite. Here is minus infinite. We want to find the magnetic field at this point, which is placed at a perpendicular distance r. This point is P. We want to find the value of magnetic field at this point. P. Current I is flowing in upward direction. In a long wire, I current is flowing in upward direction. We want to find the magnetic field at point P. We want to find the magnetic field intensity at a perpendicular distance r from the wire. That is at point P. This angle is 90 degree. The magnetic field at point P depends on the current flowing in the wire. If we increase the current, then the magnetic field will also increase. Also depends on the distance of this point P from the wire, means perpendicular distance. If we increase the distance, suppose this point is here, here or here. If we increase the distance, then the magnetic field or the effect of the current at this point will decrease. Point P, it depends on number one, the intensity of current in the wire. If we increase the current, then magnetic field at point P will also increase. Or in a hint, we can write it: on increasing the current, B will also increase. B means here B is magnetic field intensity. Number second point, it depends on the perpendicular distance r. It depends on the perpendicular distance of point P from the wire. It means in hint, if we increase the distance, then B will decrease. Okay, the third point, it also depends the medium of surrounding. Third point is, it also depends on the medium of the surroundings. With the help of equations number 1 and points 1, 2 and 3, we can also write magnetic field intensity, that's B is mu naught I upon 2 pi and R. Here R is distance, I is current. What is mu? Here mu is known as mu naught is permeability of the medium. Here permeability means how it will resist the magnetic field that is produced by the current, and its value is mu is constant. This one is constant. On next term I will take numericals depends on this magnetic field produced by the current in the wire.